Hello. Yesterday we were doing a question that I'm going to solve today. We left it somewhere in middle. So let us begin with that problem at first, and we'll do a few more problems on multiple expansion as we go along. Okay. So problem where we were stuck was a problem from Griffith only, and just give me a minute. Just give me a minute. Okay, that would do, I think. So. Okay. So Bharat has entered. ओके सो भरत समझ में आ रहा है ना कोई दिक्कत तो नहीं है ओके ठीक है so we were doing a problem yesterday and in that problem it was given that the charge density rho as a function of r was given by I think it was 1 upon r square and then it was capital R minus 2r sine of theta, isn't it? ये था. Okay, so this was our charge density given to us and it was asked that at asymptotic at some large distances, which of the term would dominate, right? Is that so? Like, check okay. So it was k upon r square, and there was again an r, capital R also here. So k capital R upon r square, capital R minus 2r sin theta. And we wanted to find an approximate potential. We wanted to find an approximate potential. We wanted to find an approximate potential on the z-axis. On the z-axis, very far away from the sphere, far away from the sphere. So this is what we were intending to find, right? And we found that total charge is equal to 0. And this charge density was carried by a sphere of radius capital R. So this is something that we've already done, a sphere of radius capital R. We also found that the dipole contribution to the potential is also 0. Yes, isn't it? And we wanted to find what is the net quadrupole contribution to the potential, and that we'll get by integral, and integral. There would be three integral: 0 to r, 0 to pi, and then 0 to 2 pi. And then I would write 3 cos square theta minus 1 upon 2, and there would be, I think, r square, right? So there would be some r square also here. And then I will write this k, I will take common out, so this is fine. And then this will be capital R and divided by small r square, then you have this capital R minus this 2r, and then you have the sine theta, and you have r square sine theta which is sine theta d theta d phi dr. Is that clear? Bharat again, no? Bharat, are you there?
Yes, sir.
Okay. So this is what we wanted to find. So we wanted to find this V quadrupole, and this is like small k. Then you will take integration from 0 to pi, and then again we'll take integration from 2 pi, and then integration from 0 to capital R. Let us first see what all terms are getting cancelled. So this term is getting cancelled. Okay, and okay, so this term gets cancelled. The remaining terms is like I will write capital R minus 2r, and there is r cube. So एक काम करते हैं, इन सबको लिख ही लेते हैं पटन से. So this will be like r square minus 2 r cube. I'll not write here, बाद में देख लेंगे इसको. This will be 1 by 2 बाहर कर लेते हैं. So this will be 3 cos square theta. अच्छा, ये sin square theta हो जाएगा. So I'll write 3 cos square theta sin square theta minus 1 and एक और r आना चाहिए, right? ये r भी तो रह गया, ये r को बाहर ही ले लो, ठीक है. Then you have some d phi also. So I'll write d phi as, चलो बाद में देख लेंगे, d phi को d theta and d phi. So I'll write what I will simply take, and for just don't get confused. I mean, this is not that k. So 1 upon that also term we have forgotten. So उसको तो लिखना पड़ेगा, divided by 4 pi epsilon naught. I will write r cube. Isn't it? That part also we have to write. So we have to write 1 upon 4 pi epsilon naught. R cube also we have to write, right? So I will write here 1 upon 4 pi epsilon naught r cube. Is that clear? ये चीज समझ में आ गई? ये r cube तो आएगा because we want to write the potential for the quadrupole. So now you just see there is no as such phi term, dependent term. So this integration will give you 2 pi. So this 2 pi will come out. And I'll write k. And this k is not 1 upon 4 pi epsilon. This is in general some constant k. R. And then you have this 8. You have pi. You have epsilon naught. You have r cube. And you see, if you integrate this stuff, I mean, एक काम करते हैं, एक integration 0 से लेकर r लगी कर लेते हैं. That will be, I'll simply write it. ये कितना हो जाएगा? It will be r into r cube upon 3, and then you can write 2 into r cube power 4 upon 4. And then again you will write integration from 0 से लेकर pi. एक काम करते हैं, इसको लिख देते हैं 1 minus sin square theta. So it will be 3 sin square theta. This is 1. नहीं, this will be 1 minus ना, तो ये हो जाएगा 2 sin square theta. इसको लिखो 1 minus sin square theta. So नहीं, 2 भी नहीं रहेगा, नहीं कितना हो जाएगा? इसको लिखते हैं, मैं यहाँ पे लिखता हूँ. So this is, I think, कुछ गलती तो नहीं कर रहा हूँ. अच्छा, यहाँ पे भी तो sin square theta आएगा. ठीक है, this sin square theta will get multiplied here. So इसको लिखते हैं 3 1 minus sin square theta. तो हो जाएगा 3 minus 1 2 and then minus 3 sin की power 4 theta d theta. So this is 2 sin square theta from 0 to pi and then minus 3 sin की power 4 theta d theta. Is that clear? Okay. And finally, I can write this as, I'll write it as 2 pi, then I will write k, and then I will write r, and then I will write 8 pi epsilon naught, and then I'll write r cube. If I replace this r here, so this will be r की power 4 divided by 3 minus r की power 4 divided by 2. This is 2 by. ठीक है? And this integration, you know that this एक काम कर सकते हैं, एक और 2 बाहर लो. This will be integration from 0, and you can write 0 to pi by 2, and then you have 1 plus cos 2 theta, because 2 sines 1 minus cos 2 theta, sorry, 1 minus cos 2 theta would give you 2 sin square theta minus 3 यहाँ पे आई जाएगा, इंटीग्रेशन फ्रॉम 0 से लेकर pi by 2. This is 1 minus cos 2 theta divided by 2 the whole square, and then you have d theta. Okay, this is what it is. So eventually this V quadrupole is given by 4 pi k r divided by 8 pi epsilon naught, and then you have this r cube. Okay, and then I will write this 2 minus, this will be minus r की power 4 upon 6, r की power 4 upon 6, and then let us find this integration. So first integration, you will get simply pi upon 2, because if you integrate cos 2 theta, you will get sin 2 theta at pi by 2. This will be 0, at 0 also it will be 0, and minus 3. And if you integrate this stuff out, so if I integrate this also, what I'll get? I will simply get 1 upon 4 minus, this is this would be, I think, this would be, I think, 4, and then there would be some, I'll write simply 2 here, and then there it would be plus cos square 2 theta divided by 4. Isn't it? ये चीज तो सही है ना? Okay, so now if I integrate this entire thing, अरे यार इसको ढंग से लिखते हैं. If I integrate this entire, like this remaining stuff, what I'll get V quadrupole is equivalent to writing minus 4 pi k and then r, then divided by 8 pi epsilon naught r cube. I'll write r की power 4 upon 6, and then you have this pi by 2 minus this 1 by 4 would give you 1 by 4 would give you what? I think 1 by 4 d theta is theta by 4, and then I'll write 3 pi upon 8, and then this integral will become 0 because cos 2 theta integration becomes 0, and minus 3 0, and this 4 bahar kar do, 0 to pi by 2 cos square 2 theta, you write I think 1 plus cos 4 theta divided by 2, so this will be 8. Okay, and eventually if you want to again this will again give you pi by 2 from here, so this will be pi by 16, I guess. कोई गलती होगी ना तो अपना कचरा हो जाएगा भी. So this is 3 pi by 2, this is minus 3 pi by 8, and I hope कोई गलती नहीं हुई होगी, है ना, because 4 will come out and cos square 2 theta will लिख दो 1 plus cos 4 theta divided by 2, so एक और 2 आ जाएगा, so minus 3 upon 8 and pi upon 2 also, so this will be minus 3 pi upon 16. Okay, so this entire term will remain. I'm not saying कि ये नहीं रहेगा, and overall we are writing v quadrupole okay, so v quadrupole is minus 4 pi k capital R divided by 8 pi epsilon naught r cube, then I'll add r की power 4 upon 6, and this is pi by 2 minus 3 pi by 16, so this is 1 and this is half, so this is 1 by 2 or 3 by 2 of it, so 3 by 2 of चलो मैं ढंग से कर देता हूँ इसको, so this will be like 16 common ले लो somewhere. If I take a 16 common, this is 8 pi minus this is 16, sorry, this is 6 pi, and then you have this 3 pi over there, so it is minus pi upon 16, so it will be minus, so I'll write minus pi upon 16 minus minus plus, so it is 4 pi square k r की पावर 5 अपॉन 16 तो है ही अपनी जगह, 16 into 6 is 16 into 6 इसके काम करता है, इसको ऐसे रन देते हैं, कुछ काट पीट नहीं क्या, सो एक काम करते रुक जाओ, सो माइनस 4 पाई के आर की पावर 5 की जगह आर की पावर 6 हो जाएगा, आई थिंक ये क्या होगा, आर की पावर 5 ही तो रहेगा, सॉरी आर की पावर 5 ही रहेगा यहाँ पर, जो भी अब आंसर आ रहा है माइनस 5/16 प्लस प्लस तो ये हो ही गया, और if I want to replace this, so this 4 would cancel this, so this is 4 into 6 24 24 into 8, तो इधर लिख देता हूँ मैं यार 24 into 8 by epsilon naught r cube, बस खत्म. ठीक है, तो इसको तुम लिखना चाहो तो you can write in this ultimately this is your waterfall. Okay, is that clear? Is that clear or not clear? So your quadrupole moment is और थोड़ा solve कर लेते हैं, जिससे कि so your quadrupole moment should come out as this pi would get cancelled, so I'll write pi here and then k r की power 5 upon 24 into 8 कितना होता है 8 2 3 3 16 192, so 192, and then I will write epsilon naught and r cube, and see what we wanted to find, we wanted to find at any distance on the z axis. So let's say this is your sphere and this is your z axis, so even like on z axis also, if I want to take this r, so instead of writing r you can write as well as z only, because if this is your theta, when theta tends to, when theta is equal to 0 only then z is equal to r ना, तो z क्या होता है r cos theta होता है, so theta की जगह 0 रखोगे तो z equal to r हो जाएगा, so on z axis your quadrupole as a function of z would come out as pi k upon r की power 5. I hope this is the answer, you just verify on your own. Is that clear? कहाँ चले गए सारे?
यस सर.
Okay, so this is the
सर
हाँ बोलो.
सर एक डाउट था कि जो हम बाहर 1/4 पे एप्सिलॉन नॉट आर क्यूब लिखते हैं, वो आर तो हमारा कांस्टेंट रहता है, लेकिन अंदर जो हम आर डैश लगाते थे वो वेरिएबल रहता था. इसमें हमने दोनों आर ले लिए, वो वैसे ही ले लिए ना, मतलब
नहीं नहीं नहीं, वो जो आर डैश, इसलिए मैं कह रहा था ये जो आर डैश अंदर लिखा हुआ बेटा, ये आर डैश ही है, इन दिस इज आर डैश ओनली। तो
बट
मैं
हमने
उस,
दोनों आर लिए ना सर।
यहाँ आर डैश, ये आर डैश और ये डी आर डैश ही, देखो इधर मैंने इंटीग्रेट नहीं किया है, यहाँ मैंने बाहर ही रख दिया इसको,
हाँ
और
जी।
इस वाले को ही इंटीग्रेट किया है। सो एक्चुअली मैं इसलिए बोलता हूँ कि अगर कंफ्यूज होते हो तो इसको आर डैश लिखो, कोई दिक्कत नहीं, दिस इज आर डैश, दिस इज आर, इन दैट केस,
ओके सर।
है ना। अगर कंफ्यूज होते हो तो अंडर, मतलब बाकी अगर नहीं होते हो तो इस वाले को मतलब बार बार डैश डैश लिखने से परेशान होगा कुछ भी। मैंने ये ऐसा नहीं किया कि मैं इसको अंदर लेके क्यों, अगर मैं इसको अंदर लेके चला जाता आर क्यूब को तो फिर वो एरर हो जाती, तुम समझ रहे हो, फिर ये आर डैश अगर नहीं लिखता तो फिर मैं कुछ कैंसिल कर देता यहाँ पे। हालांकि मैंने यहाँ पे आर क्यूब को बाहर ही रखा हुआ है, देखो थ्रू आउट, आई हैव नॉट टेकन दिस पर्टिकुलर थिंग इनसाइड एनीवेयर। समझ पा रहा हूँ मैं क्या कह रहा हूँ,
यस सर, यस सर।
है ना। सो ओके, चलो आगे बढ़े।
और सर,
हाँ बोलो।
सर एक सर एक क्वेश्चन था उसमें ना, वन डायमेंशन में अ, मतलब एक्स एक्सिस पे प्लस माइनस एक्स नॉट पे डायरेक्ट डेल्टा ये दे रखी है चार्ज डेंसिटी।
हम्म।
सर उसमें हम यही अप्रोच यूज करेंगे मल्टीपोल एक्सपेंशन वाली?
या मुझे देखना
तो
पड़ेगा,
मतलब
मैंने कल भी तुमने मुझे को क्वेश्चन भेजा, मुझे एक दिन दे दो, आज वापस भेज दो, वापस जो तुम बोल रहे हो ना क्वेश्चन, वो वापस देख लो, मुझे भेज दो, मैं देख लूंगी एक बार तुम्हारा क्वेश्चन, राइट। विल दैट बी
जी सर।
फाइन ना? तो
हाँ जी।
ठीक है। सो अभी हम आगे बढ़ते हैं, एक क्वेश्चन देखते हैं जो एग्जाम का ही है। लेट मी सी, मल्टीपोल एक्सपेंशन, तो अभी तक समझ में तो आ गया ना मल्टीपोल एक्सपेंशन, ओवरऑल इट इज जस्ट एन एक्सटेंशन फॉर योर लेजेंडस पॉलिनोमियल, तो मतलब वो मैथमेटिकल टॉपिक ही रहेगा सच, मतलब समझ पा रहे हो, इट इज नॉट दैट डिफिकल्ट टॉपिक।
सर मतलब मेरा सर ये डाउट था कि अ, हम जैसे पोटेंशियल, इलेक्ट्रिक फील्ड, ये सब तो हम एक दूसरी क्वांटिटी से हम कैलकुलेट कर सकते हैं। जैसे अब
हम्म
रो दिया हुआ है सर, इस जो हमने अभी क्वेश्चन किया इसमें भी रो दिया हुआ था, और
हम्म।
इसमें हम वो वाली इक्वेशन डेल डॉट इज इक्वल टू रो बाय एप्सिलॉन नॉट लगा के इलेक्ट्रिक फील्ड निकाल लें, फिर वहां से पोटेंशियल निकाल लें। क्या वो इक्विवेलेंट है इस अप्रोच, पोटेंशियल निकालना और उससे?
मतलब तुम ये कहना चाह रहे हो कि अगर मतलब जैसे फॉर एग्जांपल तुम ये कहना चाह रहे हो, पर यहाँ बेटा ना रो दे रखा है तुमको, राइट। हाँ तो यहाँ चार्ज जीरो था तो यहाँ तुम लगा सकते हो, राइट, यहाँ तुम कर सकते हो, बिकॉज यहाँ टोटल चार्ज जो है वो तुम्हारा एज सच जीरो है, तो यहाँ तुम्हारा काम बन जाएगा। बट हर जगह नहीं बनेगा, बिकॉज हर जगह डेल स्क्वायर बी इक्वल टू जीरो लाना, मतलब इट इज नॉट पॉसिबल। हालांकि यहाँ पर दिस इज अ चार्ज फ्री रीजन, राइट। सो यहाँ तुम कर सकते हो, पर इवेंचुअली तुम जानते हो कि वो क्या कहते हैं, अगर डेल स्क्वायर वी इक्वल टू जीरो करोगे और सॉल्व करोगे तो लेजेंडस पॉलिनोमियल में एंड अप करेगा इवेंचुअली, मतलब समझ पा रहे हो। यहाँ पर भी तुम बेसिकली कर क्या रहे हो, लेजेंडस पॉलिनोमियल ही तो आ रहे हैं अंदर कहीं भी। सो आई आई थिंक दिस विल वर्क एनीवे, बट यू नीड टू चेक इट, यहाँ इट मे वर्क, बिकॉज दिस इज व्हाट आई फील। बाकी फिर तुम्हें एक बार करना पड़ेगा इसको वर्कआउट। ओके।
सर जहाँ पे अगर मतलब चार्ज जीरो नहीं भी होगा वहां पे डेल डॉट ई वाली इक्वेशन तो लगा सकते हैं ना हम?
हाँ डेल्टा टी वेल दैट यू कैन, that you can do, and you can find electric field and probably then you can differentiate or do something like
ओके सर।
that. Okay, so we'll see, अभी एक काम करते हैं, we'll do a few more questions and देखो एक क्वेश्चन जो तो एग्जाम में है वही देखते हैं। So this particular question was asked in gate exam. Okay, and question was saying that an insulating sphere carries a charge density given by rho r is equals to rho naught, and it was given a minus r square, and then it was given I think cos theta, and r is less than a. Okay, the leading term, question says the leading term for the electric field, not potential, we need to see. So electric field, कभी कभी यहाँ गलतियां होती है, इलेक्ट्रिक फील्ड at a distance d, at a distance d, far away from the charge distribution, far away from the charge distribution is given by, ठीक है, या is proportional to. So it was given, it was proportional to d की power -1, d की power -2, d की power -3, d की power -4. So this is what it was asked. Okay, so this is another question that one needs to see. Okay, let us take this question at first. ठीक है, इसको एक बार अपन ध्यान से देखते हैं. So how to go about this problem? So okay, so this is our problem. Let us do it. Okay, so हमें पता है. Let us first try to find total charge, because if total charge is zero, then the net contribution from the monopole would be zero. So let us first find what is the charge. So इसका हमको a sphere of radius a, of radius a. Okay, so this is the radius, and inside you know that this charge density is given. So let us take 0 to a integral rho naught a square minus r square dr integration 0 से लेकर pi एक और r square आएगा, sorry, and then you will have sin theta cos theta d theta, and then you will have integration 0 से लेकर 2 pi, and this will be d pi. Is that clear? This integration would be 0. Clearly you can see that this integration would be 0, because sin theta cos theta would give you sin 2 theta divided by 2, 0 से 2 pi integrate go, this will come out as 0. Is that clear? And if this is 0, that implies your total charge is 0. If your total charge is 0, the contribution from monopoles to the potential would be 0. Is that clear?
Yes, sir.
Okay, since this is 0, now we'll have to see some few more things. So another thing would be, if this is 0, let us try to find what is the cost if there is certain dipole contribution to it. So that is found by integration from 0 से लेकर pi, integration from 0 से लेकर 2 pi, integration from 0 से लेकर a, and I will have r cosine theta, right? It will be r cosine theta only, r की power 1 p1 cos theta, and then you have this r square rho naught a square minus r square, and then again you have this some cos theta term is also there, so this will be cos square theta, then there would be some sin theta as well, and then d5 would be there, d theta would be there, and dr would be there. Is that clear? ठीक है, अब हम लोग इसको लिखने की कोशिश करते हैं. What will be our v dipole? So v dipole would be integral 0 से लेकर 2 pi. This is d5, and write d5 here. Integration 0 से लेकर pi. This will be equivalent to writing cos square theta into sin theta d theta. Is that clear? And then integration 0 to a. This is rho naught. This is a square r square minus r की power 4d. Is that clear? ये सही है ना? देखो r cube होगा, sorry, r cube होगा. So this is r cube, and this is 355. Is that clear? ये चीज सही लिखना, हम लोग चेक करो, है ना? This
सर
r,
एक बार क्वेश्चन दिखा दीजिए.
हाँ, rho r is given by rho naught a square minus r square cos theta, where r is less than a. The leading term for electric field at distance d away from the charge distribution
ओके सर.
is directly
ओके सर.
proportional to what? So हम देखें किसके डायरेक्टली प्रोपोर्शनल होगा. तो ये चीज समझ में आ गई. So v dipole now would be equal to, this is 2 pi, clear. This will be 2 by 3, because cos square theta, if you take as t, this will be 1 to minus 1, then minus 1 to 1 you can take, and this will be t square by t square dt. This will be t cube by 3, so this will be 2 pi by 3. Sorry, 2 by 3. And what about this integral? हाँ बोलो.
सर बाहर भी k by r square वाली टर्म.
Sorry, 1 upon 4 pi epsilon r 1 upon
सर r
8
square.
r square 1 upon 4 pi epsilon r square, sorry. So यहाँ पे आएगा 1 upon 4 pi epsilon r square, sorry. ठीक है, so this is, ठीक है, I think this is clear. ये चीज समझ में आ गई. And this integral will be rho naught, यहाँ पे आएगा आपके पास, and then you have this a square r cube dr. A square r cube कितना हो जाएगा? This will be a square, this will be a की power 4 upon 4, and then minus a की power 6 upon 6, right? ये चीज तो clear है. So this will be a की power 4 minus a की power 6 will be a की power 4 upon 12, and then you have this rho naught, you have this 4, so this will be pi. So एक बार ढंग से लिख दो, 4 pi upon 3, so this will be like 3 into 4 is 12, and then you have this pi and this 7, and it is asking at a very far distance d. So instead of r you can write d. So v dipole at a very far away distance d can be written as I think this pi would get cancelled. You have this 4 by 12 will be 3, right? यहाँ तक कोई गलती तो नहीं ना? So this 4 by 12 would be 3, 1 by 3, sorry, 1 by 3, and this 1 by 36. So this is rho naught e to power 4 divided by 36, and then you have this right. So this will be epsilon naught, and this will be d square. Okay, so your potential is directly proportional to 1 upon d square. So your electric field will be directly proportional to 1 upon dq. So answer, I believe, should be 1 upon dq. Okay, so this is it. Okay, is that clear? So mostly you'll
Yes, sir.
find in exam only such questions are asked. I will do as we go along. So even we'll take small question, different questions also.
सर 2/3
Okay.
आपने बीच वाली टर्म इंटीग्रल की वैल्यू लिखी थी cos स्क्वायर थीटा sin थीटा डी थीटा थी
हाँ बेटा क्या बोल रहे हो? हाँ 2/3
वो
is cos square theta sin theta d theta. Because cos square theta को अगर cos theta को तुम t लोगे तो this is t square. This will be minus dt from 1 to -1, और इसको -1 to 1 क्या दो फिर तो t
यस
square का इंटीग्रल होगा t cube by 3. So this will give you, I think this is fine. ठीक है.
यस सर
एग्जाम में बच्चे पता है क्या करते हैं, बिकॉज दे नो कि लीडिंग टर्म का क्वेश्चन है, दे जस्ट सी दिस एंड दे कम, आई डोंट नो हाउ दे कम टू कंक्लूजन. Probably quadrupole is a difficult thing to find in exam because at times it involves a lengthy calculation, and at times it may be like if it is not asked in one radial direction, then it may give you uh, it may enter into a like writing a tensor sort of thing for it. We'll see that also. But अभी के लिए एक और क्वेश्चन करने की कोशिश करते हैं, that is also easier one. I think this was asked in. So try to do this question. Okay, try to do this question. Okay, so the next question is in a sphere. Like for a sphere, now I'm giving you. If you want to find a dipole moment, then how to do it? Okay, so just give me a minute. It was here. Yes. So we want to find the first thing that we want to find is that uh, consider a spherical shell of radius r. Consider a spherical shell of radius capital R, which carries a surface charge, sigma is equal to k cos theta. So if it carries surface charge density sigma is equal to k cos theta, one needs to find what will be the dipole moment. The first thing is that one needs to find a dipole moment due to this charge distribution. And second, one needs to find is what would be an approximate potential at faraway points from the center. Approximate potential. So this is what we need to find. Okay. So how to go about it? Okay. Okay. So if you want to find this, what I've told you in the very first slide, if you want to find the dipole moment, what do? We have to find integral r vector. So I'll write integral r vector dq. This is how you find your dipole, isn't it? And if I want to make us एक बार इसको थोड़ा सा visualize कर लेते हैं. So visualize कर लेते हैं. So better visualize this. So this is my sphere. कहाँ गया यार ये? This is my sphere. Okay, this is my sphere. And it is said that this particular sphere carries a charge density which is equivalent to k cos theta. So k cos theta means what? So in the like spherical polar coordinates, we know that theta is this. So this is your theta. And if I say that my theta varies from 0 to pi by 2, that is on the upper hemisphere, you will find that there will be positive charge accumulation. On the upper hemisphere, there will be the positive charge accumulation, isn't it? And on the lower half, you will find negative charges. Is that clear? On the lower half, you'll find negative charges. And you know, by symmetry you can see that the net dipole moment will be in the z direction. Is that clear? So because you know, the dipole moment the dipole moment vector always points from negative to positive. So even if you consider any sort of, like for example, if you consider this to be one of the dipole moments, and if you take a symmetrically opposite like not symmetrically opposite, but to take a diagonally opposite vector, which is like this, if you resolve this, so the net dipole moment will be along the z direction. Is that clear?
Yes.
So net dipole moment will be along the z direction. So if the net dipole moment is along the z direction, I can simply write that my p vector would be some pk cap. It will be equal to some p vector would be equals to pk cap. Is that clear? And so p vector, if I want to integrate integration, it will be equivalent to writing, what will be this? This will be equivalent to writing rho d tau. Okay, this is equivalent to writing rho t tau. And since p vector is along z-axis, so this r I need to take along z-axis. So if I take r along z-axis, I know z is equal to r cos theta. And if I take along z-axis, so your theta becomes 0. So theta should be 0. Because if theta, if the other so in general, always remember, this is something that I'm going to write. जब भी कभी इस तरह क्वेश्चन है, always try to express your r vector in terms of Cartesian coordinates. एक बार के लिए ऐसे किया तो, so I'll write क्या कह सकते हैं, क्या लिख सकते हैं, एक्स आई के प्लस वाई जी के प्लस जेड, ठीक है, ऐसा लिख सकता हूँ. एंड माई जेड इज इक्वल टू आर कॉस थीटा, एंड ऑन द सरफेस योर आर वुड बिकम, सॉरी, your small r will become capital R. So this is how you are going to give your. Is that clear? मतलब करते क्या था उसमें, dq कहाँ प्लेस्ड है, लेट्स से जो भी dq प्लेस्ड है उसी की डिस्टेंस हम आर वेक्टर बोलते थे, राइट? याद करो. तो एक्स एक्सिस के अलोंग तो है ही नहीं कोई भी, बिकॉज आई नो दैट माय पी वेक्टर विल बी अलोंग k कैप, सो इट विल बी, आई विल राइट z हियर. ठीक है? इज दैट क्लियर? कहाँ चले गए सब
यस
लोग?
सर।
ठीक है. एंड आई नो, है ना, और मैंने तुम z k कैप, सॉरी ना, z k कैप, सो आई विल राइट k कैप आल्सो. ठीक है. और ये दोनों कंपोनेंट नहीं होने चाहिए, तो फॉरगेट अबाउट दिस, दिस ओनली कंपोनेंट शुड सर्वाइव. सो आई विल राइट p वेक्टर वुड बी इक्विवेलेंट टू राइटिंग इंटीग्रेशन, and what is z? I think it is capital R cos theta. And what is rho? Rho was given as k cos theta, so I'll write k cos theta. And then I will write d tau. What will be d tau? So on the surface, your d tau would be equivalent. D tau नहीं हो सकता. This will be sigma ds होना चाहिए, because the surface पे ही है ना चार्ज सारा, because charge on surface only ना. So dq कैसे लिखोगे? dq can be written as sigma into dA या ds. Is that clear? d sigma जो भी लिखा हूँ, इसको एक बार करते हुए है तो I'll write ds. ठीक है. So dq I can write it as sigma ds. Is that clear or not clear? देखो मेरी बात सुनने की कोशिश करो. यहाँ पर इंटीग्रेशन r वेक्टर dq क्या होता था? तो जो dq का पोजीशन वेक्टर होता था उसी को तो लिखते थे आप लोग. So dq, r vector represents the position vector of dq. So let's say if I've taken some dq from here, so this dq will be contained on the surface only. So I'll write sigma into ds. First thing is this. Second thing, understand this r vector I'll write, but in any case by symmetry I understand that only one vector would be surviving. Even if you don't want to do that, you can express xi cap y j cap also. Eventually you'll find that xi cap and y cap are going to 0 only, because x coordinate क्या होगा, वो हो जाएगा r cos theta sin theta I cap. Then this y coordinate will be r, sorry, r, ये क्या होता था, देखो ये होता था cos थीटा, यहाँ आएगा sin थीटा, और sin थीटा के बाद ये एंगल होता था phi, दिस विल बी cos phi, एंड दिस एंगल विल बी r, y कोऑर्डिनेट विल बी r sin थीटा sin phi, राइट? अगर ले भी लोगे तो होगा क्या, इंटीग्रेशन 0 से 2 पाई करोगे ये 0 हो जाएगा, इंटीग्रेशन 0 से 2 पाई करोगे तो ये 0 हो जाएगा. इज दैट क्लियर? समझ पा रहे हो मैं क्या बोल रहा हूँ? देखो
हाँ
अगर
भैया।
अगर नहीं भी लिखोगे ना ये z की क्या, तो देखो होगा क्या, अगर तुम लिखना भी चाहो आर वेक्टर को, तो आर वेक्टर क्या होता है, आर वेक्टर लिखोगे तो एक्स आई कैप वाई जे कैप, तो ये जो भी इंटीग्रेशन है ये हो गया के आर स्क्वायर यहाँ पे आ रहा है साइन थीटा कॉस थीटा जो भी है, आई थिंक कॉस स्क्वायर थीटा आ रहा है। कुछ सोचो जब एक्स कोऑर्डिनेट की बात आएगी, इफ आई वांट टू राइट द एक्स डायपोल मोमेंट का एक्स कोऑर्डिनेट, इट विल बी के आर cos square theta into r square sin theta d theta and then d phi, and what will be x? समझ पा रहे हो मेरी बात कि नहीं समझ पा रहे हो? ये तो हो गया, ये लिख दिया मैंने। फिर ये हो गया डी डी, जो जिसको एरिया बोलते हो डी एस, ठीक है। फिर एक एक्स भी तो लिखोगे, आर कॉस थीटा नहीं है, आर क्या गलती कर रहा हूँ, बोलता भी तो नहीं है बीच में। देखो ये के कॉस थीटा हो गया, दिस वाज योर सिग्मा, दिस इज योर डी ए। अब यहाँ पर आर की जगह जब पी एक्स लिख होते हैं, एक्स लिखोगे ना, एक्स क्या आएगा, आर साइन थीटा कॉस फाई नहीं आएगा, सोचो।
यस सर।
चलो मैं वैसे ढंग से बता, देखो पहली बात तो बायसिमेट्री होता है, लेकिन फिर भी बायसिमेट्री ना सुनो। व्हाट विल बी द पी एक्स वेक्टर? सो पी एक्स वेक्टर क्या होगा, इट विल बी सिंपली इंटीग्रेशन एक्स, I'll write I cap outside, and this px will be in r vector, तो r की जगह x I cap, and then this will be sigma, this is p k cos theta, and then there would be uh, this will be r square sin theta d theta d phi. Is that clear? What would be x coordinate? So x coordinate would be integration, I'll write r, I will write sin theta, and then I will write uh, this is k
कॉस।
cos theta, this is r square, this is sin theta, this is d theta. This is all from theta equal to 0 से लेकर pi, and then there would be another term from 0 से लेकर 2 pi, because x contains r sin theta and then it also contains cos pi d phi. So this term in any way would go to 0. Similarly, if you want to find the y component of the electric field, this some term would come here, and there would be 0 से लेकर 2 pi, and here it would be sin phi. Is that clear? This is what I'm trying to explain. So this anyway would go to 0. So in any case, there would be only one component, and that one component would be along k cap.
ओके सर।
दिस इज व्हाट आई वांट टू कन्वे। अगर इसको वैसे नहीं समझ पाते हो, ट्वेल्थ स्टैंडर्ड से बी ओनली सर्वाइविंग टू ट्वेल्थ स्टैंडर्ड से समझते हो, तो ट्वेल्थ स्टैंडर्ड टीचर्स बोलते हैं, या क्या बोलते हैं कि डायपोल मोमेंट ऑलवेज पॉइंट्स फ्रॉम नेगेटिव टू पॉजिटिव। सो अगर थोड़ा ध्यान से देखोगे तो इफेक्टिवली तुम्हारा नेट डायपोल मोमेंट विल बी अलोंग जेड डायरेक्शन, बाय सिमेट्री आल्सो इट इज क्वाइट क्लियर। ओके, सो नाउ z will be r cos theta, rho would be rho क्या था, सॉरी, k cos theta, ds क्या था, r square sin theta, I'll write d theta, I'll write d phi. Okay, so this integration from 0 to pi here and from 0 to 2 pi would give you what? So it will give you 2 pi, it will give you r cube, it will give you k, and then you have this integration from 0 to pi. This is cos square theta, and then there is sin theta. ठीक, अभी थोड़ी देर पहले इसका इंटीग्रेशन किया था, इंटीग्रेशन to come out as 2 by 3. So effectively, I know that p vector would be along the k cap direction, and it is 2 pi k r cube, sorry, 4 pi a r cube upon 3 k cap. Is that clear? So this will be the net dipole moment due to this, due to sphere containing such a charge distribution, which is given by k cos theta. Is that clear or not clear? ये चीज समझ में आ गई?
हाँ भैया।
Okay, so I hope this is clear. We'll meet in the next lecture and we'll do the remaining problem there itself. Okay. अच्छा कर ही लेते हैं ना, 2 मिनट लगेंगे। So next is what we want to find. What we want to find is the approximate potentials. First, find what is the monopole contribution. So monopole contribution will be equals to rho d tau. So what will be rho? Rho is integration k cos theta, and then you have this r squares, rho d tau नहीं, sigma ds. Sigma बार बार rho d tau है, sigma ds. So sigma ds will be r square sin theta d theta d phi, and this will be 0. You can clearly see this will be 0 because this cos theta sin theta term when integrated from 0 to pi would give you 0. So in any case, only dipole moment would survive, and dipole potential due to dipole would only survive, and dipole moment we have already found. So answer would be 1 upon 4 pi epsilon naught, and you have this r square, and then this dipole, you can write it here. So this will be 4 pi upon 3 and then d of k. So this will be p cos theta hota tha. So what was dipole moment? Dipole moment p cos theta divided by 4 pi epsilon naught r square. This is what is v dipole. Just replace the value here and we'll get the answer. Is that clear?
Yes. So cos थीटा वाली टर्म 1 हो जाएगी ना.